Dear friends, welcome back to Data Analytics Talks. Today I have an interesting task for you. The global superstore is operating in India across all states, concentrating on multiple cities. I have some data for you. We want to prepare a proper data model for the upcoming executive dashboards. We will be concentrating on the dimensional data modeling. And in the previous data set, we never had any dimensions or facts. It is a plain data sheet that were shared with you. I am sure this will be an interesting activity for you. Before going into the actual implementation, we need to understand few things. So when we built our first dashboard for the global superstore, we did not consider anything about the modeling. We created our dashboard with the data we received as it is. How was the data that looked? When we look closer to the data, you can see that it was a row column format. It's a table, and it contained both descriptive data as well as the measures or the numerical values. But there are some drawbacks of maintaining data in this format. As the volume grows, the data becomes big data, and this is going to impact the performance, and it will give a very much load on the data retrieval part. As per our dimensional modeling concepts, this has dimensions has to be extracted from here, and you need to maintain a fact table and create proper relationship among the dimension table and fact table. Probably we should go with a star schema or snowflake schema. Though this is not a data modeling session, as a data analyst who is building data intelligence, so it's good to know about data modeling, especially the dimensional data modeling. What is the dimension data modeling? So this is one of the data modeling techniques used in the data warehouse design, and it is also one of the major design used in many of the OLAP systems. OLAP is online analytical data processing system. In this system, the importance is given to data retrieval, and it is optimizing the select operation. In data warehouses, data is stored in such a way that it is easier to store and retrieve the data once stored in data warehouse. There are two elements in a dimensional data model. They are fact and dimension. So let's look in what is a fact. A fact is the measurable data element that represent the business metrics of interest. A business might be knowing how much quantity sold and what are the products sold in a region, in an area. For example, the business wanted to know which is the fast moving product. That is a metric of interest. That's a fact. Similarly, there is dimension. Dimensions are the descriptive data elements that are used to categorize or classify the data. For example, the business may be interested to know which location the product has sold the most. And the business also may be interested to know which product are sold the most and which product are sold the least, right? They are descriptive data elements. But when it comes to the fact, they are measurable data elements. Okay. They do not have any description in it at all. Majorly facts and dimensions. Okay. You will often hear this fact table and dimension table when you start developing some data warehouse applications and any data analytics projects. Another important concept is attributes. The characteristics of dimension in a data modeling are known as attributes. These are used to filter search facts. These attributes are used to filter or search the facts. So for a dimension location, there could be city, country, latitude, longitude, and state, zip code, etc. So hope you understand what is a fact, what is a dimension, what are the attributes. So these are three key components that should remember. The other concepts are like, in the dimensional model, the tables are arranged like a star, right? This looks like a star. You can draw a star within this design, right? What is a fact table? What is a dimension table? You will often hear about fact table and dimension table. In a dimension modeling, the fact table is a central table, like you have the sales table here, that contain measures or metrics of interest surrounded by dimension table that describe the attributes of the measures. These dimension tables are related to the fact table through foreign key relationship. This dimension table location is related to sales table through the ID, right? Location ID. Here we have the location ID. And the employee table is related to the sales table using the employee ID. And product table is related to sales table using the product ID and here the product ID, right? Hope you got a fair idea about the fact tables and dimension table, facts, dimension, and attributes. I hope this is good enough to start your data design modeling. So let's start with our exercise. We have been given the sales data information of the global superstore for the India region, and the data is given in an Excel sheet which has got multiple tabs. And each tab is a table. We can map each tab into a table. And we have sales information, we have product information, customer information, employee information, and location information. Look at the location information. We have ID, each location has an ID. It has the city names, country, and we only having country India. Then the zip code, latitude, longitude, and state is Assam, Meghalaya, all the states of India. So you understand that this is a dimension table. This is not a fact table because this is not containing the measurable metrics, right? And we have the employee table. So employee table only having the employee name and ID. Then customer is also having ID and customer name. Then we have the products. The products ID, product name, price, margin, then tax rate. So again, this is not a fact table, right? Because it has descriptive information in it. But coming to the sales, there is no descriptive elements at all. Everything is measurable items, right? And what is the key is we have the date and quantity. Date and quantity. Then we have the ID, customer ID. It will be related to dimension, customer dimension. Location will be related to location dimension. Product will be related to product dimension. Employee will be related to employee dimension. We will be using the dimension tables to search and filter this fact table. So let's try to see how we load this data into a Power BI data set. Okay, let me open the Power BI. I have the Power BI open and go back. You will see there is no data set being loaded into that. So let's do one thing. Let's go to the options and settings. Here we have data source settings as well as options. In the options, we can see how the data load to be controlled. Under current file option, we have something called data load. Here you can see type dictation, relationship, and time intelligence, then background data, etc. Very important to uncheck the import relationship from the data source in the first load. For example, when you load an Excel file or any data from any source, it will start identifying the relationship and will import it from the source itself as it is getting loaded. But since we are doing an exercise, we don't need to we don't need the Power BI to import the relationship from the data source on the first load. So I am just unchecking that. So let me click OK. So it's time for us to get the data. Okay, let's go to the data set. Let me get the file. I have the sales data for India. Okay, I need to. So this is a important thing that you cannot open in. You cannot load an open file. So I need to close it. Now I can retry. So it's connecting. As I mentioned, each tab is a table, right? We have customer, employee, location, product, and sales. We would like to load all of these tables. So let's connect. Let's check each one of them. I forgot to select the sales. Let me select sales 2. So we have a preview option. You can preview the data before we load it. So let me load it. As you see, we have completed the data load of the dimension tables and fact table. As a next step, we need to build a proper relationship between these tables. In Power BI, we have different ways of setting or managing relationship. Okay, let's arrange these tables in a manner so that we can identify what is the fact table, what is the dimension table. So we have employee dimension, we have location dimension, we have the fact table as a sales table, customer and product as dimension table. There are many ways to manage relationship. You can either drag and drop the attributes and create the relationship, or you can go manually and auto detect the relationship among the tables, or you can create a new relationship using this create relationship interface. So I select customer, the customer ID. I am going to connect to sales fact table. So the customer ID, I made a relationship from customer to the sales fact table using the manage relationship. Similarly, I can track this attribute to the sales employee ID. So we have this relationship from employee to sales. Again, I have the product ID to the sales. We can check the granularity in the relationship. Here again, I have a location ID. This is an ID. I can drag on to the top of the sales table. This is how we have set the relationship. Now we are able to search or filter the sales fact table using this dimension table. Unless and until you have this relationship, you cannot do that search or filter of this fact table from the dimension table. Therefore, building a proper relationship among the dimension table and the fact table is very much necessary for building a proper visualized dashboard reporting. I hope you understood about the database modeling, especially the star schema. In the star schema, the fact table will be in the center and the dimension table will be around the fact table. Our data modeling is complete. Now let's move on to the report view and try to use the relationship in the visualization process. Today I will be using a table. Let's pull some attributes. Let's start from customer. Let's have the customer name. Then we have employee who sold the product. Then we have country. Then we have the state. then city. Then we should choose the product, price, tax rate, profit margin. Then coming to the fact table, which is the measure table, we will choose the quantity, and from the date we will go for year and quarter. Okay, so we have all the required information available. So we are able to bring related information from multiple tables because we have a proper relationship among them. Okay, if you remember our last session when we were building the global superstore analytical dashboard, we were using a single table, but today we are able to use multiple tables to build a report. So if I want to know specifically which state has sold, so let's add a slicer. We can go and add a slicer. To the slicer, you can drag the state, and probably we will set the slicer settings to tiles. Let's make it little small. We can always rearrange our controls based on our UI UX design. So if I want to know the sales happen in Kerala, I can go for it. Okay, if so, based on your selection, you will be able to see the data for the corresponding state. So if you want multiple states, you can choose that too. So we are able to do all this because there is a proper relationship. So now you are able to build your global superstore analytical dashboard for India region based on the leadership requirements. So we have done a proper data modeling for the given data. Hope this session was useful. If you have any comments, please make that in the comment section. Thank you. So when we built our first dashboard for the global superstore, we did not consider